Hey, what is going on, guys? And welcome. And in this video, we're going to be doing something a little bit different than our regularly scheduled uh, content. So a few days ago, I was asked by an audience member. Hopefully, I don't butcher their username, but Rihan Shaikh asked a few days ago if I could make a video covering loops in depth. Now, so that's what I'm going to do in this video. We're going to talk about loops as a, a, a mechanism in programming and talk about the principles of loops. And hopefully, the information that I'm able to provide helps not just uh, Rihan, but everybody that's watching these videos to get a better understanding of some of these topics that we cover. We cover a range of. I mean, I don't want to sound out of touch, but some topics are a little bit easier than others. Some topics may look easy on the surface, but if you dive deeper, you might find yourself asking deeper questions. So hopefully, I can be able to help everybody watching these videos to understand certain topics a little bit better. So thank you for asking the question. If anybody has any question at all about any of the topics and lessons we go through, don't hesitate to ask. I can again. I made this promise that I will make videos. I will respond in comments, and I will engage with any questions to help people understand these topics that we're learning in programming a bit better. So in this video, we're going to talk about loops. Again, we're going to talk about the principles of loops, and these principles will apply to every programming language because virtually every programming language has loops implementation of some sort. So so let's start talking about loops. What are loops? So I want you to picture a scenario where you are an entry level programmer and uh, maybe you're in class and you're learning programming, right? You're taking a programming course and your professor asks you, right, before you've even learned what loops are, right, how to write loops, your professor asks you without using any shortcuts, write a program that prints the string hello world 5 times, right? So no keyboard shortcuts, no other advanced mechanism to having you to writing this program that prints hello world 5 times. Now what you will do, most likely, is just open up your programming environment. We're in our handy dandy Python playground, right? And just create a new file and just print hello world and do this 5 times. Hello world. Print hello world a third time. Print hello world a fourth time. And then finally print hello world a fifth time and run our program to make sure it's working. And there we go. We've written a program that prints the string hello world 5 times. Okay, that was tedious and a little bit annoying. But then your instructor, your professor says, hey, I want your program now to print the string hello world 50 times, right? And again, you can't use any shortcuts or any advanced mechanisms of any kind, but your program needs to print the string hello world 50 times, right? So you're going to have to sit there and print hello world over and over and over and over again until you've reached 50 statements, right? 50 times that you're calling the print function and you're passing the string hello world to that to the print function. So you have to do that 50 times. So hello world over and over and over. And here I'm using keyboard shortcuts just for the sake of explaining, but there we go, right? All the way down here until we've reached 50 lines. Now when we run this, our program prints hello world 50 times, right? So now imagine um, you're a teacher now, right? And you're teaching a class of 100 students, and you have to sit there and you have to grade 100 exams, right? And the only way to do it without any advanced mechanisms will be to go through each paper one by one and grade it for accuracy, right? So the idea that I want you to have in your mind is this act of doing something over and over and over again for a specified amount of times. Now, in programming, a scenario in which you have to do this, right? If you have to write a program that does the same thing or repetitive task over and over again, is where the mechanisms of using a loop comes in, right? Loops allow us to execute a code block repeatedly until some condition is satisfied or some sequence has been fully processed. Okay, so when I say a condition is met, what do I mean? So in programming, right, in Python, you also come across this in JavaScript, in TypeScript, in Java, in C++. We have two types of built-in loops. You have the while loop and you have the for loop. For something in something, right, do something. And then here we have while condition is true, do something. And we'll talk a little bit more about the anatomy and the ingredients of creating each loop. So we'll start with while loops and then go on to for loops. But while loops can perform an action as long as a certain condition is true and allows it to go into the body of the while loop and to perform some task. On the other hand, for loops are iterate over sequences, right? Over data types in Python that are considered a sequence or are iterable. Now, what do I mean by iterable? I mean a data type in which we can access elements of that data type, right? Items inside the data type that we can index, right? That we can target, right? If I say, for example, my list is equal to 1, 2, 3, 4, 5, 6, and I wanted to print my list, right? This index, I can do print my list at index 5, right? And when I run this, we get the number 6, right? Because I can go and I can target each individual item in this list one by one. Same thing I can do with a string, right? If I do my string is equal to hello world, right? And I wanted to print this O, right? It's what characters? 1, 2, 3, 4, 5. It's the fifth letter. I'll have to do print my my string 4, right? And that's gonna print the O, right? So any data type, and you can do this with tuples, you can do this with dictionaries, right? Anything that I can target in this kind of thing, in this kind of manner, that's what a sequence is. It's something that we can iterate over, we can index, we can target individual items contained within them, and that's what for loops are really good at doing. So let's talk about while loop, right? The ingredients of a while loop. So in order to write a while loop, we need to use the reserved keyword while, right? This tells Python that we're writing a while loop. And we're going to say while x is less than 10, print x. And now, but look at this though. The way we write while loops, it tends to require, now you can kind of do this a little bit in line, but it takes a little bit more to create a while loop than it would for a for loop. So, for example, so let's run this code actually. I'm sorry, this should be while x is equal to 0, not 10, right? There we go. So we have to create a starting position. We have to check a condition that will get us to a point where we can exit the loop. Then we can perform some action. And the most important part is to make sure that we increment our starting position so we can get closer to the terminating to the terminating point of our condition here. So what is this loop, right? So let's really talk about this loop a little bit more in terms of what's happening, right? First, we tell Python this is our starting position, right? We create a helper variable called x. We assign it this value integer 0. Then in our while loop, we ask what our condition is while our starting position is less than 10, print x, and then increment x by 1. So Python's basically going to go, hey, x is currently 0. Is 0 less than 10? If it's true, it's true. So we go into the body of the while loop and then we print x. So at that point, x is 0, so we print 0. And then we have to increment x by 1. And then we go back to the top of the loop. Now x is the value 1. Is 1 less than 10? Yes. So we go inside the body of the while loop and we print 1. And then we increment x by 1, so now x becomes 2. We check again, is 2 less than 10? It is, so we print 2. And then we increment x by 1, so now x becomes 3. And then we do that over and over and over, so now we get to the point where x is equal to 9. Is 9 less than 10? True. We print 9, and then we increment x by 1, so now x becomes 10. Is 10 less than 10? No. 10 is equal to 10, so we do not execute anything inside the body of the while loop. And if we had some extra line over here, we can print final value of x and pass x, and now you'll see x is 10, right? Once we get to a point where this condition is no longer evaluating to true, then we don't do anything. When x is 10, we ask, is 10 less than 10? No, 10 is equal to 10. So we don't do anything. We don't print 10, and we certainly don't increment 10 by 1. We kick ourselves out of the loop, and we come to this final print statement. So that's how a while loop works, right? A while loop will execute a code block as long as a given condition remains true. When the condition becomes false, the line immediately, right? Any line of code that immediately follows our loop will be executed. So in this instance, this print statement will be what comes after. And if we had a longer program, right, and we'll keep writing more code down here, for example, then our program will continue functioning as normal, right? So that's really the case. So while loops, while they work and they function, good and they're useful, if you are not careful, they can get you into what's called an infinite loop. Well, how do we get in an infinite loop? Well, if you remember, our loop has to check if a condition is true in order for it to continue executing what's inside the loop block. So every single time we check if x is less than 10, right? But what happens and we have to make sure that our loop gets us closer to the point where this condition is no longer true, so we don't stay in here forever. So what's the important thing that we have to do to make sure that we get to exit this loop? We have to increment x by 1. Now what happens if I don't do this, right? If I leave x, if I just print x and don't do anything else, right? I'll run the code here, and you can see we're just constantly printing 0. And this will continue going on forever and ever and ever and ever and ever. As you can see, I can scroll all the way down and it's still printing 0. You can see it down on the bottom of the screen here. It's still printing 0, right? So what's happening? Essentially, we tell Python, hey, our starting position is 0. Then in our while loop, we check if our condition, right, if x is less than 10, and then we tell Python to print x. And that's it, right? Python's going to print x, and it's going to go back to the top of the loop, and it's going to check again. The value of x hasn't changed. So x is still equal to 0. So Python's going to ask, is 0 less than 10? True. Print 0. Go back to the top of the loop. Is 0 less than 10? It's true. Print 0. And it's going to keep doing this over and over and over and over again, right? Because we're not giving Python a way to get to a point where this condition no longer evaluates to true. That's why we have to tell Python, hey, once you print x, the value of x, increment it by 1. And then now when we run this code, our loop finally terminates here. And again, print final value of x, right? And this might be even an easier way to see it. Again, if I comment this out, this incrementation of x, which is what we use in our condition check, right? We'll never reach this code block. As you can see, we're just going to keep continuously printing 0 forever. We're never going to get to this code block. So that's why it's important to include in your while loop a way for us to get to a point where this condition terminates, right? It evaluates to false. And that way, our loop will run, and then we'll finally print out a value or continue with the rest of our program. Now, this going into an infinite loop is also possible while using a while true loop, right? While true, which is the same thing as doing this, right? As long as this evaluates to true, then do something, right? Go into the body and do something. But this way, we can just say, while true, this will run forever, right? Even if we don't, uh, uh, you know, do anything here. This will also run forever because we're not telling Python a way to break us out of here, right? So this will also put us in an infinite loop and we'll never reach this code block, right? So how can we exit this true? Well, we can check if x is greater than or equal to 10, then break. Otherwise, print x and then increment x by 1, right? So now when we run this, our loop will exit once we print from 0 to 9, and then we can reach the next block of code, right? So we always have to have a way for us to break out of our while loop, and we have to be mindful when we're writing while loops to always include a way for us to get out of these loops. Now, you're probably wondering, well, if this is an issue, right? Well, what's good for using a while loop? So I'll explain. So while loops are usually pretty useful if you're writing a dynamic program that has to run for an unknown amount of times. So we've done examples of this in some of our videos covering the course. Say, for example, I want to write a program that asks a user to provide 2 inputs, and once those inputs are provided, do some calculation, and then keep doing it over and over again. And I'll demonstrate here. So I'll say while true, right? A is equal to input, and I'll wrap this in an integer function. Input, please enter the first number, and then this will be B, and then we'll say print A plus B, right? So let's run this. So let's say, for example, I have a sheet of paper next to me, and it has a bunch of integers that I need to add over and over and over again. So maybe the first number is 10. Oh, I should change this to the second number. So let's run this again. Please enter the first number, 10. Please enter the second number, 15, right? In fact, just to make this even a little bit easier to read, we can say, we use an F string here, and we say A plus B is equal to A plus B, like that. Now let's run this. So our first number will be 10, our second number will be 15. 10 plus 15 is equal to 25. And then so now I have maybe, 15 of these on my sheet, but my computer doesn't know that, right? My program doesn't know that I need to do this 15 times. So maybe I give it another number, 20 and 25. 20 and 25 is 45, et cetera, right? So in an instance like this, where our program has to take in values and we need to do something over and over again, but we don't know how many times we need to do it, because we might have to do it 5 times, we might have to do it 6 times, et cetera, then using a while loop, like a while true loop, becomes super, super useful. And then we can also say, enter 0 to exit. So now, if A, and then you can check, if A equals 0, break, right? Otherwise, continue doing this. So now look what happens, right? Please enter the first number, enter 0 to exit. If I do, for example, 10, and then 15, 20, 25, 30, 12, right? But if I enter 0, my program ends, right? I could print here, program terminating, like that. So now again, if I could enter 0, program terminating. But I can also go back in and I can do this a bunch of times, right? I can do this as many times as I want, but as long as there's a way for me to get out, boom, I can exit the program by entering the digit 0. Now, if I was to enter this here, right, it will still work, but it'll ask me for both values first before it kicks us out. So let's, for example, here, I enter 0 and I enter 1, then it kicks us out. But it will be easier for us to put this first if I want this to terminate after entering the first value. So we'll put that right in the middle. So as you can see, a program like this is great because I can use it however many times I need to perform some amount of arithmetic operations, right, additions, and then when I'm done, I could just enter 0 and exit, right? So a while loop in this initialization process is really, really good. But again, I have to remember I need a way to get out of this. Otherwise, right, if I don't have this, then guess what? I'll just have to stay in here forever, right? Even if I type in 0, if I enter 11, nothing happens, right? I'm always going to be stuck in here, and I'll have to manually stop my program from executing when I'm done. So this is another instance in which a while loop is really, really good. And if you ever take a college course, your professor will probably tell you this, right? While loops, we can use them, and they're pretty useful when they're used to do something an unknown amount of times. You want to repeat a task an unknown amount of times, a while loop is great, right? As long as you set up a way for you to exit that loop. So hopefully that helped you guys understand a while loop. So just be mindful that if you don't have a way for you to exit the while loop, you will fall into what's called an infinite loop in which your program will run forever. We saw that earlier with the example of printing the string hello world or printing the value of x, right? If I don't set up a way for me to exit my loop, then the loop will continue running forever and your program will never reach the point where it can run the remaining code in it. So hopefully that helped you guys understand what's going on when it comes to for loops. Now, let's talk about, while loops. So now let's talk about for loops. So what are for loops good for? And I said it earlier, right? We talked about while loops are good for doing something while a certain condition is true until that condition is no longer true. For loops are good for iterating over a sequence, right? And again, a sequence is anything we can index and target the values inside of it. So a list, a tuple, a string, right? These are, or we've also seen the range function, right? These are all ways for us to use a while loop. Now, let's look at the anatomy of a while loop. So I'll use the range function for this example. So I say for I in range 0, in range maybe 10, print I. Now look, right? If I was to do this with a while loop, I have to create a helper variable outside of this called I, set that equal to 0, then do while I is less than 10, print I, and then I plus equals 1, right? With a for loop, I did this in 2 lines. With a while loop, I did this in 1, 2, 3, and 4 lines, right? Both do the exact same thing. In fact, I should probably put a print here to separate them, right? Both did the exact same thing, printed the digits from 0 to 9, right? Incrementing, but a for loop did it in a much more succinct way, right? In a much more concise way. Now, this range function, as you guys remember, just is a way to iterate over a given starting and ending position. If we only pass one argument in it, then Python is going to starting counting at 0 up to this number, but not including it. If I wanted to include 10 in the printout, I would have to go up to 11 like this. So now I have 10 involved, right? This is another way of me starting from 0 and go up to 11, right? So when I pass 2 arguments, the first argument is the starting position. The second argument is the ending position, the ending number, not including it. So this will print from 0 to 10, right, and not include 11, right? So another way to do this would 10 plus 1, whatever, right? We'll still do the same exact thing. So I can also have a high starting, my starting position can be 10 down to 0, and if I pass a third argument, this is telling Python how many steps to take. So I want to go from 10 to 0 and by decreasing by 1. So now if I run this, I get from 10 down to 1. Right? Again, starting number is included, ending number is not included. So that's what's going on in this range function. As you can see, for example, So that's the difference between a for loop and a while loop, right? A while loop takes a little bit to set up. And I also have to remember to have some sort of incrementing command in here to make sure that we can get to a point where we can exit the loop. But a for loop, the nature of a for loop is, right, it's really, really good working with sequences. And so as long as we still have items in our sequence to process, this loop will run. And once it's gone through the entire sequence, then it will stop. So let's take a look at this while using a list. So if I say my list is equal to A, B, C, D, E, F, and then G, I can say for letter in, right, my list, print letter, right? There we go. We get each letter printed out in sequence from beginning to end. So this is what's really, really, really useful about for loops, right? I can give it a sequence, and it'll do something with what we want to do with that sequence in the body of the loop. It's a lot more succinct to set up, and because it's working with sequences, it will continue to process items in a sequence until the entire sequence is processed, then we don't have to worry about going into a for loop, right? Python, or the anatomy of a for loop itself, already takes care of that, right? It takes care of incrementing for us. Right? We don't have to tell Python to move up each index manually, right? The for loop does that for us. We don't have to tell Python to make sure to stop at the end of the sequence, right? The for loop does that for us. So that's why using a for loop is a lot more useful, right? And again, going back to my earlier point when I was saying that while loops are really good for doing an action an unknown amount of times, while for loops are really good for doing an action for a known amount of times, right? What we learned in the course, what was referred to as definite iteration, right? Definite knowing, we know when it's going to end, right? That's why for loops are a little bit useful. Now, for loops, as we've seen, for loops and while loops do the exact same thing, right? It's just the way we set them up is how it becomes a little bit more difficult because, again, if you're not careful with a for loop, you can, and to have a mechanism that increments or gets us out of the while loop, right? Then we can stay in there forever and crash our program. But for loops, we don't have to worry about that. And as we demonstrated, while loops are really good if you want to run a program that we don't know how many times we're going to run for, and maybe that our program needs to take in inputs over and over and over again. While loops are really, really good for that. So another thing that's really, really good for loops, again, something else just for demonstration purposes, we can say, maybe we want to say for index in my list, we can even do range of my list, like that. We can print my list at index. Oh, and this will do the same thing, right? So, we can set this up in a multitude of ways, right? Using the range function, we give the length of my list. So my list would be 1, 2, 3, 4, 5, 6, 7. So this would be another way of just passing the number 7 here, right? And it does the same thing. And we can print so when my list at position 0, it prints the A. My list at position 1 prints the B. My list at position 2 prints the C, then D, then E, then F, down to the very last item. So, that's really, really the difference between a while loop and a for loop. Rehan also asked me, which one's better between a for loop and a while loop. Now, again, it really depends, right? And I know that answer might not be what people are hoping for, but it really does depend. Again, as we've seen, if I need to write a program that has to run for an unknown amount of times, then a while loop might be a better option because I can keep it running for as long as I need to, as long as I have a way for me to get out of that loop by either, right, if my program takes in an input, by checking to see if the given input is a certain value, and then using that certain value to kick us out of the loop, or having a mechanism, some sort of mechanism that basically helps us get out of the loop. But if my program only has to iterate over a list or a string, right? And actually, I should have demonstrated that. My string is equal to hello world, and I can do for letter in my string print letter, right? And there we go. In fact, I should probably put a separator print statement here for us, right? So a string is something that I can also iterate over, because I can do this. I can do print my string at 0 and get an individual letter, right? So I can get this H printed. So if I know that I'm going to be writing a program that iterates over a sequence, right, a list, a string, a tuple, etc., then a for loop might be a better approach to my program. Now, while both can do similarly the same things, that's really the trade-offs, right, where the benefits come from using either or. Another thing that for loops might be a little better at is writing nested loops, for example, right? So for example, say for I in range 5, and then for j in range I, print I, like that, and then see what happens, right? Then we print these numbers, 1, then 2, 2, then 3. I can print this little pyramid here, right? So nested loops are another way that we can really take advantage of for loops. So as you remember, for example, when we are working with matrices, right? So I can have a nested matrix here with a bunch of letters like this, and I can say for range I in length of matrix, right, I need to set this above the loop, and then for range and then right. So if I wanted to print each child of the matrix, A, B, C, D, E, F, G, H, right, then nested for loops are really good at doing that. So nested loops are another way we can do that, right? A loop inside another loop is, so as you saw earlier, we were able to do this for I in range 1 to 5, for j in range of I, print I, and then print a new line, right? We can print this half pyramid like this. So what's happening here? We're saying for this variable I will be assigned a number, doing iteration, a number between 1 and 5. So it's going to start at 1 and up to 5, not including it. And then j will be for range of I. So the first time this loop runs, the value of I is 1, and the value of j will also be 1. So it prints 1. Then iterate over again. I is now 2, right? Now j will be in range from 0, right? This is the same thing from 0 to I. So now it'll be from 0 to 2. And then it prints 2, right? Because we already printed the 1. And then same thing, right? When I becomes 2, and then we print the 3s, and then we print the 4s, and then so on and so forth. So if I can even set this up to 10, and you can see we can build a pretty long half pyramid here like this. So there was another exercise in which we had to do this, if I remember correctly, right? Print this half pyramid like that. That's why for loops are really, really good, right? Because I know, right, if I have to print this half pyramid, that's how many levels? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 levels tall. Then I can just use the range function in a for loop and pass, from 1 to 10, right? Because it's not going to include 10, so it's going to run 9 times, and get this half pyramid printed like this. So that's really what is useful for loops. So I hope that helps you understand the differences between for loops and while loops, why we use one over another, right? What scenarios we can use one or the other, things to be mindful of. Now I'm going to make a follow-up video to this one in which we're going to cover some similar exercises that we covered over in the course, the Python course that we've been covering over for the past couple of months. So we'll have some exercises in there. They're going to use while loops. They're going to use for loops, and I'm going to talk you through them as as we're going through these exercises. So thank you for watching. If you're still a little unsure, let me know in the comments below, and this goes out to everybody watching. Let me know in the comments below, and I will continue covering this topic until we get it down pat, until we can all understand it and fully digest it, and know when we're reading instructions for an exercise, we can say, hey, here I think it'll be good to use a while loop, or there might be a good idea to use a for loop, and so on and so forth. So stay tuned. In the second video, we're going to go through some examples and solve those exercises using while loops and for loops, and then we'll go on from there. And after that, we'll continue with the rest of our regular content.